Hi, in this video, I'll be explaining problem number 29 of chapter 16, section 1. Match the functions f with the plots of their gradient vector fields labeled 1 through 4. Give reasons for your choices. F of xy equal to x squared plus y squared. The four graphs are given. So we are going to find out the gradient vector field for this function, scalar function f of xy. So the gradient vector field is made up of gradient vectors at every point. So which will be f sub xi plus f sub yj in 2 dimensions. Del f of xy is f sub xi plus f sub yj. F is given to be x squared plus y squared. So f sub x will be 2x, f sub y will be 2y. So del f is 2xi plus 2yj. So this is the gradient vector at every point xy. By looking at this, we can compare the vector xy, which is a position vector at the point xy, with the gradient vector 2x, 2y at the point xy. We notice that the direction of 2x, 2y is same as the position vector at the point xy, but the length will be twice the length of the position vector at the point xy. So 2x, 2y vector, or vector 2xi plus 2yj, in this case it is the gradient vector, has the same direction and twice the length of the position vector of the point xy. So if you take an example for this, so let's say we take the point 1, 2, then the gradient at that point 1, 2 would be 2 times xi, 1i, plus 2 times yj, which is 2j, which is 2 times 1i plus 2j. Thus, del f at the point 1, 2 will have the same direction as the position vector of the point 1, 2, but the length is twice. So we observe the following about this del f, the vector field del f. First one, vectors at the points in the first quadrant will have positive x and positive y, will be pointing towards the first quadrant. Will have its x component positive and y component positive as well, but the lengths are all twice. But with double the length of the position vector. And number 2, if you take any vector in any quadrant, vectors at each quadrant will point towards that quadrant, will point in the direction of that quadrant, which means quadrant 2 vectors will point towards negative x and positive y. Quadrant 2 vectors will point in the direction of negative x and positive y. Thirdly, we notice that as the points move away from the origin, meaning either x or y increase, as the points move away from the origin, meaning that either x or y increase in value, then their lengths, the vector lengths would increase. So we have these observations. Putting these observations together, we notice that the best fit, the best match for the gradient vector field is graph number 3. Hope this video helps.